Hello children, good evening all of you. I hope I am clear. Yeah, today's session is all about the basic physics. Like this is Anupama from Spark Academy, and today we are going to learn about the basic physics. What all are the important concepts which are required for learning physics for MSET, NEET, and also, for all other competitive exams. Okay, so we will discuss that, but before that, we will just go through like the the important topics which are here in our this thing. So you can see here, right? So this session is all about the basic concepts of physics, as I told you. So now, okay, yeah. Now, like before we go for the previous year MCQs and all, let us know first about the Spark Academy. Okay, you all know how important how important role physics plays in different competitive exams, isn't it? So, for all the competitive exams, whatever you are going to write, the simple physics, basic physics, that foundation is must. So, before entering into the higher lessons, the other lessons, we'll just learn about the basics in the physics. But now, like before we go there, we will just you all know about the Spark Academy. Just try to download the app and then try to know the courses which all are there here. And yeah, once you download the app, you will come to know what all are the courses which are available here. Okay, so and the next here, yeah, we have live sessions in the Spark Academy already recorded. Even if you miss the live classes, you can just, once you download the app, you can just see all the recorded classes. Like for example, you are missing one class today due to some technical reasons or due to some some other reasons, right? So you need not worry, you can just open the app and already the recorded sessions will be there in the app. You can just see the recorded videos, or while you are revising also, like you, this app will be helpful to you, because already the videos are available, so that will be helpful to you, right? So this is about the app, and you can see the assignments. We have homeworks like online through, we will give the assignments, and then every week you have a test and the assessment on the test. Like the assessment of your result will also be there here. And then yeah, and we have even the previous year question papers too, which are available in the app. See, once you download it, you'll come to know the previous year question papers are also available in the app. You can just open at any time once you are login, and then you subscribe, then you can just know all these things. And then, as you all know, we have online and offline coaching, and on NEET, MSET, and advanced, and also IIT Foundation. Okay, so this is about the Spark Academy, and I am Anupama. This is Anupama from Spark Academy, and today we are going to discuss about, as I told you, the basics of physics, whatever are required for learning physics chapters. That basics we will just discuss. Okay, right. So what is the basic thing here is, like, topic wise weightage means, as you are in the foundation, like once you learn the topics, you will come to know the weightage actually. But when it comes to the MSET or NEET, there are few topics which are very, very important, which plays the crucial role. Like, the first year, if you take first year intermediate, the mechanics, the total mechanics. And then in the second year, we have electricity, light and all. So, and electricity meaning it's not only current electricity, we have electrostatics, electromagnetism, and magnetic induction. All these things, all these lessons are there which are related to electricity topic, right? So these are the important things which, a topic wise, these are the very important thing. Like, as you know, we have like kinematics. Okay, kinematics we have, and then we have the work, power and energy. Okay, right? And then Newton's laws, circular and rotatory motion, and gravitation. Okay, and gravitation. These all comes under this mechanics only, right? So this is about mechanics topics. And like rotatory motion means we have actually rotational mechanics, a very big chapter and interesting too, right? So this is, these are the first year weightage topics. And coming to the second year, as I told you, we have the electricity. The total electricity is very, very important. As I told you, electricity, we have different concepts which are related to electricity. All comes under this. And then next, even the light too, right? That is ray optics. Okay. So these are the very important chapters. Okay. So anyways, we will learn step by step. This is only the initial and introduction of the topics. We will learn step by step. But before I go and start, actually, what all of these topics and all, I think you all know what is actually physics and how it plays an important role in our day-to-day life, isn't it, right? So that knowledge, I think you all have, right? So anyways, we will discuss, right? We will know, like, see what are the points will be covered, miss. That is what I am saying. Like, here, for example, today we are going to learn about the basic concepts. Okay, like before we go for the higher chapters, we will just discuss about the basic concepts of physics, which plays an important role. Okay, so I hope you all know that physics is all based on the physical quantities and all that, right? So physical quantities are those which are measurable. Like, we will discuss, we will every day-to-day life, we will use those physical quantities, but some of us may not be knowing that they are called as physical quantities. Okay, for example, we measure length, we measure area, volume, mass, time, every day we will do that, right? But we may not be knowing that those all are the physical quantities. We call them as physical quantities. But in fact, all those quantities which are measurable, which you can measure, are called as physical quantities. Okay, we have so many physical quantities actually. See, we can measure too many things, isn't it, right, around us? Okay, so all these are called as, which are measurable are called as physical quantities, which you can measure are called as physical quantities. Okay, and these physical quantities are divided into two types. I hope you all know this. This is only the revision what you already know. Okay, so these all physical quantities are divided into two types. One is the fundamental quantities, and the second one is the and the second one fundamental quantities, and the second one is the derived quantities. Okay, fundamental quantities and derived. I hope you all are able to see this. Fundamental quantities and derived quantities. Okay, what are the fundamental quantities? Fundamental quantities are basic, means they are independent of other quantities. They don't depend on others. Okay, they are fundamental, like how these alphabets are very much useful for us in the English language to build the words and all. The same way, even these fundamental quantities are also very much useful for us, or very important role they play for building of higher physical quantities. Okay, initially there are only 3 fundamental quantities. Like, I think you know this, isn't it? Length, mass and time. Right, these are the basic fundamental quantities initially we have, and the remaining all comes under derived quantities. We are calling them as derived quantities because they all are depending on the fundamental quantities, or they all are they all are derived from the fundamental quantities. Like, for example, we have area. Okay, area is equals to length into breadth. That is the formula we have. An example I am taking. Or you can also take half b into h. Example, isn't it? This is area of a rectangle or a triangle, whatever it may be. On what factor does it depends? It is depending on the breadth and the height, or it is depending on the length and the breadth. Meaning it is derived from 2 lengths, isn't it? So that is the reason why this is called as a derived quantities. Okay, like except these 3, all others are derived, like area, volume, okay, and then density. All others are derived quantities only. Okay, except these 3 initially. And then we have like these are the fundamental and derived quantities we have. And then there are like some system of units are also there. Like, I think you know about the units, isn't it? Units are nothing but which plays very important role. Like, in terms of units, you can define a physical quantity as physical quantity is equals to numerical value into unit. Okay, numerical value into units, right? So what are the numerical values we have here? Like, the numerical value means it's like a number into any unit will give you the correct meaning for the physical quantity. Okay, you can just say n into u. Okay, or if physical quantity is kept constant, n is inversely proportional to u also you can take. Okay, so in this way you can relate the numerical values and the units, right? So how many types of units we have? We have CGS, you have MKS, you have FPS and all that, right? And also SI system. But at present we are using the SI system only, that is System International, SI units. Like, we have 7 actually in SI system. That is the first 3 are from the previous fundamental only, length, mass and time. Okay, apart from, what is the unit of length? In MKSI system, the unit of length is meter. And what is the unit of mass? It is kilogram. Okay, and the unit of time is second. Unit of time is second. And apart from all the 3 what we have already discussed, we also have few you also have few things which can be added to the SI system here. Those are amount of substance, and the unit of amount of substance is mole. Okay, and then we have temperature. Unit of temperature is Kelvin. And then we have length, mass, time, amount of substance, temperature, luminous intensity. Okay, luminous intensity is what you call is a candela. It is all about light, isn't it? Which is related to light. That is candela, luminous intensity. And then you have electric current too. Electric current also comes under the fundamental quantity, and the unit is ampere. So these are few SI units, the 7 SI units. Apart from these, we also have some supplementary units. Okay. Along with this, we have some supplementary units too. Okay. What are these supplementary units? I mean, angles comes under this supplementary units. One is plane angle. Plane angle is nothing but it is represented by theta. Like if you join two lines, what you will get? You will get an angle, isn't it, right? So this is what is called as a plane angle. Okay, and the unit of plane angle is radian. Okay, and then we have solid angle. This is actually, which is plane angle, is usually related to a two-dimensional sphere where two lines are attached, and then you get in a two-dimensional. For example, the angle in a circle, the angle in a circular disc, or something like that, which comes under two-dimensional figures. All of them are this. Okay, next we have solid angle. Solid angle comes under 3 dimension, which is represented by omega, and the unit is steradian. Okay, steradian. This is how it is. Solid angle, this is angle, here it comes. The 3-dimensional thing. So these are about the units, SI units and all. Okay, we can convert one system of unit to another system of unit. That is all about, the physics. I mean, learning about the physical quantities, isn't it? By knowing the units, we will come to know whether the quantity belongs to the higher thing or the lower thing. Okay, for example, I say 10 kilograms of sugar. Okay, and the same way I say 1000 grams, or I say 50 grams of sugar. Immediately by seeing the units, you will come to know which is more in quantity, isn't it, right? So in this way, units or the system of units helps us to know about the quantity of that particular physical quantity. Okay, like for example, 1 millimeter and compare with 1 kilometer, which is greater. Naturally, by seeing the unit itself, you can say 1 kilometer is greater than 1 millimeter, isn't it, right? So in this way, units are helpful for us. Now what we will do is, we'll just discuss about a few question and answers. Okay, so as I told you, subscribe to this channel and then get the benefits. Okay, right, we have few questions here. The act of measuring the required quantity is called as what? This is measurement. Okay, and physical quantity, as I told you, numerical value into standard unit, right? And then kilowatt hour is the unit of power. Candela is the SI unit of luminous intensity. I hope just now I told you, isn't it, right? Luminous intensity. And then we have numerical value. I think I told you just now, numerical value is inversely proportional to the unit of the physical quantity. Like here it comes. Okay, and the next one, I hope this is clear, right? And the next one, if you take, if U and U2 are the units of the physical quantity, see, it is inversely proportional to U, isn't it? That means you will get N1 by N2 is equals to U2 by U1. So B is the unit. And the unit of mass in FPS system. There is a system which is called as FPS. F meaning foot, unit of length. P meaning pound, unit of mass. S meaning second, unit of time. So now he is asking the unit of mass in FPS system, which is pound. Okay. The fundamental unit which is common in CGS and SI system is that is second only. Like in all the systems, the unit of time will be common. Okay. It is common everywhere. Right. The physical quantities which are independent of other physical quantities are called as, as I told you, fundamental quantities are independent of other physical quantities. They don't depend. Whereas derived quantity depends on fundamental quantities. Right? Which of the following is a fundamental quantity? R, he is saying. Okay, we will see. Fundamental quantity, not unit. Kilogram is a unit. Second is a unit. Acceleration is a derived quantity. So time is the fundamental quantity. The symbol used for unit of time is T, small t. The unit of plane angle is radian. Area, volume, density are the fundamental quantities or derived quantities. They all are derived quantities. Which of the following is a derived quantity? Derived unit. He is asking about the unit. Kilogram is the unit of mass, which is the fundamental quantity. Second also unit of this. This is also, meter is also unit of fundamental quantity. So meter per second. Right? So this is the thing. I hope this is clear. Next, unit of area. These are few questions which I am discussing what I told you just now. Unit of area is a derived quantity. Meter square actually. Area is meter square, which is a derived quantity. The derived unit of area is meter square. Okay. And then derived units are the units of derived physical quantities only. Fundamental units are the units of fundamental physical quantities. Derived units are the units of derived physical quantity. Okay. In SI system, all derived units are obtained by multiplying or dividing the fundamental units? No. They are independent actually. They are independent of other physical quantities. They are actually the fundamental quantities. Okay. Right. We have some multiple questions, multiple answer questions. Means one or more answers will be there. Okay. The symbol for a unit which is not named in the honor of some scientist is written in the lowercase. Usually these all are the representation of the units. Like some for example, the symbol, as I told you, kilogram we write like this. Meter with small m. Time with small t, like second with small s. Okay, so some representation are there. So usually we don't write in the plural form, and whenever you are writing short form, it will be singular form only. Okay, and some units are named under the scientist, like you can take Newton, and when Newton is the unit of force, and this is named after scientist Newton. And how do you represent it? You represent it with the capital letter N. Okay, and even another power also, like work done also. The unit of work done is joule. Okay, so joule is the unit of work done, and this is represented by capital M. Means those scientist names, means the units which are after scientist names, usually you represent in the capital letter form. Okay, So yeah, this is how it is. The symbol of the unit is not named in the honor of some scientist is written. Yes, this is true, because not a scientist, right? A unit in short form is never written in plural. Yes, this is also true. Full name of the unit named in the honor of the scientist is written in lower initial letter. No, generally um, symbol for a unit which is named in the honor of the some scientist is written in initial capital letters. Yes. Actually, this is ABD. Okay. Yeah, we have this like unit of a derived quantities. We just quickly complete this. Which of the following is a derived quantity? What is the derived? Height is fundamental. This is fundamental. Mass is fundamental. Volume is derived. Which of the following are used to derive the quantity density? Density is equals to mass by volume, isn't it? So mass and volume. Which of the following is, unit of density is mass. Formula. Which of the following is a fundamental quantity? Fundamental quantity is radius. Means only single length we will measure, that is radius. Okay. So this is how we measure. We will know, or this is how we measure the fundamental and derived quantities. This is how we name or we give the units, and these are all the basics of the physics. Okay, whatever you go with, whatever more you learn about the physics, compulsory you should have high idea about all these basic physical quantities. Okay, I hope this session is useful for you all, and I hope you all have gained something from this session, and download the app and subscribe the YouTube and Telegram channels. Okay, thank you children. Bye.